Good morning, everyone. In this presentation, we will discuss one of the most fundamental topics in piping engineering, pipe materials. Choosing the right pipe material is much more than selecting a metal or a plastic. The material directly affects the safety, reliability, operating life, and overall cost of the piping system. Today, we will review the main categories of pipe materials, compare their characteristics, and understand how engineers select the most suitable material for different industrial applications. Why pipe material selections matters. Selecting the correct pipe material is one of the first and most important engineering decisions during piping design. Several factors must be considered. First, the material must withstand the operating pressure without failure. Second, it must maintain its mechanical properties at the required operating temperature. Another critical factor is corrosion. The pipe must be chemically compatible with the process fluid to prevent deterioration and leakage. Cost is also important. Engineers evaluate not only the purchase price but also fabrication, maintenance, inspection, and replacement costs throughout the system's lifetime. Finally, the selected material must provide a long service life while ensuring safe operation under all expected conditions. Metal pipe materials. Metallic materials are the most widely used in industrial piping systems. Carbon steel is the most common choice because it provides high strength, excellent buildability, and relatively low cost. It is extensively used in oil and gas facilities, power plants, and water systems. However, it is susceptible to corrosion and often requires protective coating. Stainless steel contains chromium, which forms a protective oxide layer against corrosion. It is commonly used in food processing, pharmacy plants, and chemical industries, where cleanliness and corrosion resistance are essential. Alloy steels contains additional elements such as chromium and molybdenum. These alloys improve strength and performance at high temperatures, making them suitable for refineries, boilers, and high-pressure steam services. Each metallic material offers different advantages depending on the operation conditions. Non-metallic pipe materials. Non-metallic materials are increasingly popular because of their excellent corrosion resistance and lightweight constructions. PVC is commonly used for water supply, drainage, and irrigation systems. CPVC has better temperature resistance and it is suitable for hot water and chemical transports. HDPE offers outstanding flexibility and impact resistance, making it ideal for gas distribution and underground water pipelines. FRP and GRP combine high strength with excellent corrosion resistance. These materials are frequently used in offshore facilities, desalination plants, and chemical processing industries. Although non-metallic pipes generally have lower pressure and temperature limits than metals, they provide significant advantages in corrosive environments. Material selection process. Selecting the proper pipe material follows a systematic engineering process. The first step is understanding the process fluid and its chemical properties. Next, engineers evaluate the operating pressure and temperature because these determine the required mechanical strengths. Corrosion analysis is then performed to ensure long-term durability. Finally, engineers verify that the selected material complies with applicable standards and satisfies economic requirements. The objective is to achieve the best balance between safety, performance, reliability, and cost. Summary. To summarize, pipe material selection is one of the most critical decisions in piping engineering. Carbon steel remains the most widely used material because of its strength and affordability. Stainless steel and alloy steels are selected when corrosion resistance or high temperature performance is required. Plastic and composite materials provide excellent solutions for corrosive environments and utility services. The key message is simple. The best material is not always the strongest or the cheapest. It is the material that best matches the process conditions while ensuring safety, reliability, and long-term performance. Thanks for your attention. Please subscribe for more.